mean, there is science and maths in absolutely everything you do. If you bake cakes, you're a scientist and a mathematician. You know, the chemical reaction of putting those ingredients together, measured as per mathematical formulas, creates a product which is both yummy, and sweet. But you are a scientist and a mathematician just by baking a cake.
And you get a reward at the end,
Absolutely.
which is
That's
always
the kind
good.
of science I like.
Yeah, exactly. And Rachel, I'm intrigued with one thing you said earlier was you described yourself as being a nerd when you were at school. Would you say now that stigma's somewhat dropped a little bit in that actually it is a bit cooler now, isn't it, to do science and...
Absolutely. Like, I mean, people who are, teenagers now, it's okay to be a nerd. It's fine. You can be geeky. You can watch Game of Thrones. You can, be into all of that kind of stuff, and it's okay. Whereas, maybe 20 years ago, it was a bit like, oh, they're just weird, or and actually, you can see that shift and that change. And following on from the maths there, I think, and the recipe analogy, really, that is molecular biology in a nutshell.
Mm-hmm.
We follow a recipe, and it comes completely down to maths. Add 5 microliters of this to that, incubate it at 65 degrees for 10 minutes, and it's just like cooking.
And so can you, because I was just saying earlier on that, like I said, I did like chemistry, I like the physics, and I loved biology, in fact, although I came to it rather too late on. But the maths was always very poor, and I always felt I couldn't go further because my maths wasn't up to it. Is that something that's quite common, or is that something that can be overcome? Or because presumably what we're saying that there is always that link between science and maths.
I think maths, you have to almost see it as a skill that you practice. Mm-hmm. So much like trying to learn a musical instrument, it's something that once you know how to solve a problem one way in maths, if you can do it over and over and over again, and it will always work in the same way. So it's a very logical discipline. In science, we use maths every day for things like calculating the amount of chemical to put together, the amount of powder in a chemical to make it into a solution, and that they have to be at the right concentrations for experiments to work properly and for experiments to be reproducible. So it is just something that you can tell yourself, oh, I'm not very good at it, but if you practice it enough, it does come. And there's some great websites now that can explain maths to people in really visual ways that perhaps in the past when you're doing your GCSEs it might have been really difficult to kind of go understand the concept, but now with animations and YouTube it's like, oh, okay, I get that. That's really,
it's making it exciting, isn't it?
Yeah, and it makes it so much easier to understand. So it's always worth having a look on YouTube for anything where you think, oh, I don't really understand that, I'm not very good at that. There'll be somebody who has explained it to somebody really well on YouTube.
Well, speaking of making things exciting, shall we have a go at a little experiment? Rachel has brought all manner of things with her. I've put a little picture up on our Manx Radio Instagram, actually, so you can see just explain what's in front of you here, Rachel, and what we're going to do.
So it's typical kind of DNA lab sciencey things. So I've got
typical,
yeah, typical, just one in every corner. So we've got some latex gloves mostly we use them to protect our samples from us rather than us from our samples. And we have some cheek swabs. These are ones that are used on animals, actually, rather than humans normally. And we have something called a micropipette, which is how to move around very small amounts of liquid. So in molecular biology, it's obviously everything is quite small because it's molecular. And these pipettes will move anything from about a teardrop amount of water or liquid down to absolutely kind of almost microscopic amounts of liquid. Wow. And then we have all of the little bits that go with those. So we have little disposable plastic ends for the pipette tips and things. So
amazing. She's got all manner of stuff. So
we've got some chemicals as well.
Oh, yes, there's bottles of things too. Look, there's a bottle here with a blue lid. What's in this one here?
So that one there is the fun one. That one's got something called absolute ethanol in it, which if you know your alcohol in your pubs, it's 200 proof.
It's essentially moonshine.
Yes.
Yeah, I wonder why you homed in on that one.
And this other one is sodium chloride, which most of you would just know as table salt. So, but it's at quite high concentration. So when we work out the concentrations of things, it's like how much table salt to put in water to make a particular concentration, and that's the kind of maths that I do every day, day in, day out. And that's what this is.
So what are we going to do?
Well, with the swabs, I'm going to wash one around my cheek, and that's going to break open all the little cells that are in my mouth that get attached to the swab. that'll release the DNA, and then we're going to add some chemicals, and hopefully we're going to make the DNA appear like magic out of solution into like a swirly, snotty mess.
Oh, this sounds so cool.
DNA is effectively snotty when you get it to this point, so it's quite good.
So is there anything, because I'm conscious that I don't know what this involves, but we do have a camera here. Is there anything that you could be doing, like just to show people on camera?
Yeah, so what we can do is I can do the cheek swab. So these are sterile. So one of the interesting things, the difference between DNA testing of animals and DNA testing of humans, is that when you're testing humans, you don't normally use a cheek swab. And the reason for that is that you could be swabbed in your sleep or while you're unconscious or anything like that without your consent to do DNA testing. So with human testing, normally you'd spit into a tube. So the consumer genetics companies where you might do your ancestry or something like that, you would spit into a tube for about 20 minutes to get enough DNA. Where with these, with the animals, it's you're testing your dog or your cat. So
Yeah.
So normally we'd be just swirling these around the mouth. So I will be quiet for a second.
Bit of swirling going on here now. Yeah, it's okay. You can probably hear that, you see. So you're getting a little bit, so a sample from the inside of the cheeks. It doesn't hurt. That's good.
Yeah, so she's literally just, sort of swirling it around and just picking up bits of her own DNA. She was a little bit worried there might be some McVitie's biscuit attached to that. We will see if that has any bearing on the DNA sample.
Scientists like their tea and coffee and biscuits. You have to say, there are certain protocols that you can go, there's 10 minutes in the middle of that one where I can go and get a cup of tea and a biscuit.
So what we might find out is that Rachel Glover is made up partly of biscuit.
Absolutely.
Essentially. But I mean, that's a great thing to be made up of, I think.
That can't be bad.
Mine would be chocolate. So it needs to do some things in the background, I think, doesn't it?
So what's happening is that this little blue liquid that's in this tube is just attaching to the cells and things that I scraped out of my cheek.
Right, so that's a test
and
tube and being shaped up.
bursting them open. So it's got a little bit of detergent in there. So it's a little bit like washing up liquid, basically. So this kind of process you can do in your own house with strawberries, washing up liquid and vodka. So it's something, if you go searching for strawberries and vodka on the internet, you'll probably find DNA isolation in there somewhere.
How bizarre.
So this is just the more purified version of that. So I'm just wiggling around the tube to make sure the purple liquid goes all over the DNA, and then hopefully we'll try and get it out of solution. So it's called precipitation, and that'll be the next step.
Wow.
Amazing.
So, okay.